Okay, so I wanted to talk about something that we didn't talk about in class, and this is the addition I really want you to watch. You don't need to watch the practice exam if you don't want to, but this is one that you need to. And this is really kind of the way cell membranes work too. There's a question number 13 on your practice exam, which has an ionic compound and an insoluble compound. And it's like, why is one super soluble and one is not? And we talked about the fact that it has a really soluble ionic part. Well, soap works this way too. So if you have like some kind of carboxylate, this is a carboxylic acid, but without this, it's called a carboxylate ion. And let's say you've got a ton of nonpolar stuff. I don't care how long this goes out, it can go forever, and I wish I had better handwriting. But it goes out like this, right? Forever and ever and ever and ever. This part over here is going to be really, really soluble. But if you think about it, like at some point, remember we said after like 5 carbons, stuff starts to get insoluble, right? But yet this thing is still soluble. So why is that? Well, this part over here still isn't. This we would call the non-polar. And it kind of looks like if this is like a snake, that's the head, and this would be the tail. And oftentimes we call this the polar head. Okay, so we have a polar head and a non-polar tail. And if we were to take this stuff and throw it in water, what would happen is actually really, really cool. The non-polar stuff would be afraid of water, right? So imagine you're gonna have tons of these. So the non-polar stuff, and I'm just gonna kind of draw them like a circle with that, okay? So this again is a polar head, this is a non-polar tail. The polar head wants to arrange itself so that it can dissolve in water. But the non-polar tail is like, no, leave me alone, I don't want to be near water. And so what happens is you create these things that we'll call micelles. So you can imagine it's going to create a whole little sphere like this. I'm doing a pretty bad job, but hopefully you make some sense of this, that all the polar heads are on the outside and the non-polar tails are on the inside, trying to hide away from the water, if that makes sense. And that is how this stuff would dissolve. And this is how soap works. This is why soap can dissolve in water, but it can grab grease and hold the grease inside here, but also still be in water and dissolved, which I think is really, really, really cool. So anytime you need to take care of something that maybe isn't water soluble, but you want it to be, you just add a lot of dish soap. In fact, I used to work at a bike mechanic shop, and that's what we did to dissolve the grease on chains and stuff. We would actually use dish soap to wash the chains off. So I foresee a question like this. I think this is in your topic list. It's the last question on your exam, where we're going to need to know how this works. And this is called, by the way, a micelle, but it's also a lot of how even cell membranes work. You'll have a polar head, and then you'll have tails around them. So if you've taken biology, you might have talked about this already. All right, y'all. Hope this helps.